Okay, thank you. Yes, Brett said, my name is Scholz. I'm the national German ISP, and we are offering voice over IP services. And after like 2 years, we managed to get the service up and running and stuff. And now we've got more guys coping with daily business, and we're focusing on security. And we're trying to resolve issues before they actually become any issues in Germany. Since once you've got the government looking at you, it's probably too late. So what I'm going to talk about is what voice over IP is, why we do have all the voice over IP stuff running right now. Then I'm going to look into zip fingerprinting. It's both locating devices and identifying devices, and it really fits in with the previous talk by David and Mark. Since you noticed when he was like copying the call ID and he punched in IP addresses, and if you're on the internet, you just don't know that piece of information, and you have to, at some point, just get it, and that's what I'm talking about. Then I'm talking about stacks and parsers and how they work or don't work, how to attack zip devices once you know that there's some sort of, you know the IP address, you know the kind of device, you know the issues, then you can go ahead and attack them, and eventually some conclusion and some small extra. So what is voice over IP? I'm kind of rushing through this since you've seen it a couple of minutes ago, and I've got more interesting stuff to talk about. If you're looking at Germany, we had ISDN for like 20 years. So you had all the equipment in place for 20 years that just talks ISDN, and suddenly those devices talk IP, but they hardly have seen any upgrades and any firmware, any patches. So it's traditional PSTN equipment that speaks IP, and it's been in production for 20 years, and it's in production right now, although it has never been tested. And if you look at like Google or whatever other companies guide, the growth and the potential of the market is pretty big. So all the companies are trying to get into that market as soon as possible, probably without even knowing what they're actually getting into. So my ISP used to be a PSTN carrier, and it's still a PSTN carrier. So whenever they have some issue, they just say, okay, on the PSTN side, you could just do that and get it fixed. So why don't you just go ahead and try that? And zip is just different. Voice over IP is just different. On PSTN, you have your dumb terminals. You get like 2 wires connected to your handset, and you've got all the logic running in the network. But on zip, you've got a dumb network. It's just IP, and you've got clever applications. Like you've got all the different Snom phones, Avaya, Cisco phones, soft clients like Xlite, and they're pretty powerful. And all those features are actually implemented on the client side and not on the network. So that's the key difference, and that comes into play most of the time when we're talking about any kind of bugs. This is what certain companies want you to believe how voice networks are supposed to look like. Somewhere in the middle in there, you've got some devices talking zip, but it's all billing and it's access layers and stuff. So we get it down to this. This is your typical voice over IP network. You've got split up signaling and media. You've got signaling running between devices, and signaling always goes through a zip proxy unless you're talking directly to devices. But media is supposed to directly flow between end devices. So you don't need that amount of bandwidth on your zip server, and you don't have additional latency just for traffic flowing to some random pop and flowing back to your client. That's how it's supposed to look like. I think the previous talk got it all figured out for you, so I won't talk that much about it. What you do have here is you've got some media gateway, which is your gateway towards the traditional TDM-based network, and you still do RTP on that. You send your RTP traffic based on IP towards your PSTN gateway, and that would terminate into the TDM world. But all the signaling protocols get converted from zip usually to SS7 and MGCP. So like David said in the previous talk, there's so many more protocols to take care of, and this talk's only going to focus on zip. It's the signaling protocol for most voice over IP applications. Skype uses its own protocol. Then there's H323. We've got H325 coming up at some point. But this talk's just going to talk about signaling based on zip. So now that we've got it down from the big picture, we sorted out. We're still down to one protocol. So that's supposed to be pretty easy. Just expect that to be one RFC and that's it. But this is how it looks. So in case if you lost, I just highlighted the loss numbers for you. That's most of the RFCs that actually deal with zip. There's way more to come, and there's way more that are not on that list. And in addition to all those RFCs, we do have lots of drafts. Drafts are usually additional pieces of information, ways to get things done, like your caller ID. There's one way to do caller ID that has never been standardized, but is, as a matter of fact, in production use in our network and in our peer partner networks. So although you know all the RFCs and you support all the RFCs, you still have to have a look at all the drafts, and it's a major hassle. You pretty much have one person at your company reading RFCs and drafts on a daily basis and just look what actually changed and what you have to pay attention to. Two interesting drafts that came out after the initial or the second zip RFC that's currently in use is the so-called privacy extensions. It's a new way of defining your caller ID, and there's just few devices supporting those extensions, but the devices that usually support those extensions are the major commercial devices like the PSTN gateway. And I'll talk about that later. It's a big issue that companies are not enforced to implement all those RFCs, and you might have network devices that don't have a common basis in terms of RFCs, and you're getting lots of issues with that. Then you've got the torture test. It's pretty much an RFC that has a encoded tarball attached to that. You've got broken zip messages, and you just fire those zip messages at random clients, and most of them actually break or just crash. So talking about the protocol design, it's plain text HTTP-like. You've got the request response. It's pretty easy, and if you know HTTP, it's really easy to actually understand. But what you don't see in the protocol is that the state engine, all the functionality, all the features is implemented inside the client. So supplementary services, this is what ISDN is about. Zip offers you pretty much basic phone calls, but if you're talking to some company, they want supplementary services, call ID, call hold, communication, completion of business subscriber. There's so many buzzwords. Those have not been standardized when the first zip devices came up. So most of zip devices don't know all those standards. That's one of the major issues. So how could we attack voice over IP networks? We've got all the attacks that were previously talked about, like media attacks. You can intercept media, like shown before. You can insert your own media, which is really not that easy. And you can do eavesdropping. This is what we're sort of interested when we're looking at the call patterns. What are our customers doing? Are we seeing any actual attacks? Are they like trying to call certain numbers, certain premium services? You just do number harvesting. It's much like you're collecting email addresses for spam. You start collecting phone numbers for spit. We hardly see that happening, but it's out there. So that's one of the big threats. Social threats, theft of services. I do like free communication, but I do not like paying for somebody else's free communication. So you want to make sure that nobody can actually use your billing account to make phone calls. We've got denial of service, like shown before, flooding attacks. There's actually amplification attacks, just require you to set up like up to 10 packets, and that will generate millions and billions of packets just by injecting like 10 kilobytes worth of traffic. And you've got combinations. Like the Bank of America example is pretty good, and that's what I'm usually using too. It's just, okay, you spoof some identity, and then you use RDP or like phishing attacks, just to get people to enter their PIN number or their bank account or give away some piece of information. To get to the guts of the talk, we want to attack something. Like previously shown, we want to do attacks. So what do we have to do to do an attack? We always have multiple devices, so we have to figure out some way to desynchronize those devices and make sure, okay, one device thinks the call is being torn down, so I don't have to write a billing ticket and don't have to pay for my call anymore. But like PSTN gateway still thinks, okay, the call is still going on, you can still do a PSTN call. And we want to get around IDS system or IPS systems. There are hardly intrusion detection systems on the market. Talking to ISPs, we hardly see them using those systems. And it's really easy to send packets that don't look like zip at all and not being noticed by the administrator. So I got it down to 3 steps. First of all, it's locating devices. Like if you've got a test bed on your chair, sitting on your chair, you know the IP addresses. But I'm going to talk about, okay, what's going to happen if I just don't know the IP addresses. I want to locate devices first. Then I need to identify devices. I can just look at the chat and say, okay, it's a SNOM phone. But if I'm like a couple of thousand miles away, I won't know what kind of phone or device is running on the other end. I won't know if that device has like one T1 line connected to it, or just one analog phone line, or it might be voice over IP only, so it might not be worth attacking. And eventually, we want to exploit those devices. So for locating, I've written a tool named SMAP. It's a mashup of Nmap and ZipZag. ZipZag is a basic stateless zip tool. And it's available on the CD, but I really, really recommend you get the updated version, since there's so many additions to that, and don't use the Black Hat CD version. The updated version is much more interesting, and you're going to do much more. You're going to have much more fun with that. So, what does it do in terms of locating devices? To locate a device, you just have, it's much like locating an HTTP server or locating a mail server. You just try to connect to the mail server, and if you get a response back, you know the server's running. If you get an ICMP error back, okay, it's probably not running. But on Zip, we don't have a real zip-based ping. There's a draft out for probably 2 months, and it's this third version is actually the first version that I've seen. We can ping devices, then we've got the options request as seen before. So what I did, I was crafting random messages, sending them to those devices, and you expect those devices to respond to some sort of message. I don't care if it's a 404 not found, saying, okay, the party you're trying to reach is not available, or if the party I'm trying to reach is actually registered on that device. The fact that it's responding to zip and responds to the zip message tells me that's a zip device. And at this point, that's pretty much all that I want to know. So what I do is I send all the different kinds of zip messages, and once I get a response, I know it's a zip device. I don't care what kind of response I got, as long as it starts with like the valid zip response header. And I can do basic banner grabbing, like shown before. You can just look at the user agent header and says, okay, this is running Zip Express router, or this is a SNOM phone. You can do that pretty easy. I want to do live demo, but unfortunately I don't have internet connectivity here. So I'm just going to show you in the screenshot. So what you do is you can specify either an IP address range, host name, you name it, and we'll start sending ICMP packets and try to see if the host is up. You can turn that off, much like on Nmap with -P0, and then we'll just start sending zip-based messages. And the moment it gets back a zip-based message, it lists the device as zip enabled. As you can see, I scanned 8 hosts, 7 of those were up, and 5 were zip enabled. So that's a pretty good hit ratio. I got that hit ratio since I'm scanning just IP address ranges that actually belong to one of the ISPs in Germany that offer voice over IP services. The market in Europe especially is really limited. In Germany we have like 5 or 6 big ISPs, and they are all offering voice over IP in addition to DSL networks. So you do get a dynamic IP address, but you know the IP address range where that DSL router is hooked up to. And that DSL router happens to be voice over IP enabled. So if you're looking for voice over IP enabled devices, all you have to do is just get an ISC, look up some random guy and see if his host name is in some DSL IP address range from a certain ISP, then start scanning that class C network, and the hit ratios go up to like 90%. 90% of the devices you're actually scanning are voice over IP enabled. So usually if you're just scanning random IP addresses, it's really low. Like everybody's running HTTP server on the Linux box at home, but there's just so few people that run asterisk on their home box. So knowing good IP addresses and knowing how to find locate devices fast is really important to actually do any attacks. Since if you can't find any devices, it's going to be really hard to do attacks. What are the issues? That was pretty easy to do in the first place, but what are the issues that we currently have? Most of the devices we have are DSL routers, so there are no net issues, no firewall issues whatsoever, but lots of interesting devices, like soft phones running on Windows, are behind a net. And if you manage to trigger a bug in them and just probably execute random code, it's worth way more in terms of hack value in comparison to just a DSL router. So you have to get through a net from the outside, to locate the device, to fingerprint the device, and actually exploit it. Getting through a net is kind of hard, and you can fake your IP address, but you won't get your response back. So getting the response back is one of the more difficult parts. Even if you manage to get through a net, there might still be a firewall. Like, we're making our vendors of zip devices implement firewalls so that they will only accept zip messages that are coming in from our zip servers. There's no reason for some random guy to send random zip messages to some DSL router. There's some use cases, but you can just, take a hot hook on your web interface and turn it on. But usually you don't need that. So it's really hard to get around firewalls, if there are firewalls. But this is what I came up with, and it's not being automated in the SMAP tool yet, since I'm really looking into how to get it really automated. What you do is, you do have some zip client behind a net or a firewall, and that will only speak towards your zip server, and it will only accept incoming messages from your zip server. So if I spoof the source IP address of that server, I can inject a packet, but the response would just go back to the zip server. But if I do change the signaling part, I can make the device send the packet back to me. And at the same point, since it's kind of a new communication establishment, it would open up the firewall. So I can from that point on directly send packets to that zip device, since the firewall in between just opened up the port. But it's really hard to get it right, and at some points you have to deal with the zip domain names that you just don't know at that point. So it's not being automated, but I'm planning on getting it done, sometime in the autumn, and that should be available on SMAP then. So now for fingerprinting. Generally, fingerprinting, active fingerprinting, this short primer. You just craft a random request, like for OS fingerprinting, and using Nmap. You just craft a request, and you get a reply back, and based on the reply, you expect you've got a database, and just check the reply against the database and say, okay, that's sort of device. If you're not talking about TCP flags, there's a paper called ICMP Usage and Scanning, which is pretty good. It uses ICMP messages. For instance, you send an ICMP netmask request, and if you get a response, chances are pretty high it's a SunOS box. You can trigger all sorts of bugs by sending random messages, but this can be detected really easy, since you're sending superfluous messages that usually don't show up in regular signaling. So if you're doing passive fingerprinting, you just look at the traffic you're already seeing. But the downside is you won't be able to trigger any bugs, since if you're just looking at regular traffic, there are hardly any bugs in there, since people tend to fix bugs if they can't make a call. So for zip fingerprinting, why do we actually do it? From an ISP point of view, I like to know which devices are in my network, since if you do have some bad device, like sending invites all of the time, you just try to drop those invites, or drop some of the invites, drop some of the messages to lessen the load and the impact. And eventually we believe that devices or clients that are going to inject split messages into our networks are going to look a lot different than regular DSL routers. So just by identifying those devices, we try to figure out, okay, that might be a split one, okay, that looks like a regular client, so let that one in, and that one, might be bad. But on the black hat side, you can still disguise your program. You can just look at regular signaling and make your client look like a regular client. So making fingerprinting pretty much impossible. The HoneyNet project uses the Nmap fingerprinting database to mimic the behavior of different devices. And you can do the same with clients. But we haven't seen it yet, since you won't be able to see it anyway. But we haven't hardly seen split yet, so it's we believe that that's gonna happen in a couple of years. But if you're scanning and locating zip devices, you want to know what kind of device it is. Like I said before, it might be a big IP-based PBX that has like 120 lines connected to that, or it might be just your home router that has like limited outgoing lines or whatever. So as a black hat approach, I would have to locate devices as fast as possible, since there are way more IP addresses out there and web servers out there than there are voice over IP devices. And I do want to fingerprint those devices and have to do it actively, since I won't see any traffic from those devices if I'm not sending traffic to them and looking at the responses. But from the wired approach, looking at ISP, I want to have a passive intrusion detection system or prevention system which really can cope with thousands of concurrent calls. So that's different approaches, but I thought, okay, I'm just going to go with the black hat approach and then, okay, figure out my way how to get all the knowledge and get it implemented in a passive system. So for passive fingerprinting, what do? You just look at the headers you're getting in response. Like, does some certain header actually exist? What's the order of headers? How does formatting look like? The RFC is pretty loose on some stuff, and companies tend to implement it different ways. Or you can look at like the TTL value on IP. It's an 8-bit value and it's supposed to be set like to 64 to 255, but nobody cares if it's set in 28. It's perfectly legal, and that's what Windows is doing. And you can identify a Windows machine based on the TTL. And the same is true for zip. So for active fingerprinting, you just fire random messages at the box, and it might respond or might not. And much like Nmap, based on the fact that you got a response or didn't get a response, you can look it up and you compare to your database and say, okay, that device looks like a Cisco phone. The messages that I'm using are limited. It's actually 7 messages right now. It's a regular options request. Then it's an options request that's missing the zip colon prefix to zip URI. Some devices don't understand that notation. It's actually broken, but some devices just get around that and still respond. Then I've implemented something called new method, which is an invalid method, and response should be 501 not implemented. But sometimes you just get back 400 pound or something. That's a good way to do fingerprinting. Then you just do an invite, and that might just say, okay, that extension you're trying to reach is not registered in here, so you get a 404 back, or you might get 100 trying back saying, okay, I'm trying to reach that party you're trying to reach. And provisional acknowledgement, which is hardly supported, unfortunately, and the zip ping request, which is specifically written to act as a kind of keep-alive mechanism to locate devices. You can see the source code and how the messages look like in the source code. And there's, it's pretty easy. There's some documentation how to add more requests if you want to do more of that. And yeah. So how does SMAP look like? You just add the -O option, and if you're playing around with that, you might try the -L for learning mode. I just can't show it to you since we don't have network over here. And it's just going to start sending the very same messages it sent before, but instead of just stopping at the first zip message, it sends more zip messages, builds up a fingerprint, then compares it to the database, and based on the database tells you, okay, that's that kind of DSL router, that kind of DSL router. And as you can see for the AVM Fritzbox, which is the pretty much most common DSL router in Germany, the company sold 10 million units last year alone, and we've got 30 million households, so pretty much everybody has an AVM-based router. You can even narrow down the firmware version just to a couple of releases, just by sending 7 messages. This is the same approach Nmap is doing, and there might be better ways of doing that, but until now, it's just fine. It just works with 7 messages. You don't have to have any, like the ISMP stuff Opia was doing, you don't have to have real trees and base your next request on your previous request to actually get a fingerprint. It's just 7 messages, and the hit ratio is really, really good. And we were actually able to get to DSL vendors or DSL router vendors and say, okay, you're running asterisk. We want the source code to that device before we actually looking at shipping that. And they were saying, okay, we're not, our box is not based on open source. And you just did a fingerprint and say, okay, you're running asterisk. No questions asked. And at some point, they just figured out that their guys in Asia were really doing using asterisk based on Linux for the DSL router. So we put some pressure on them, and we're going to get the source code sometime. At that point, I got distracted since I was looking at fingerprinting, and I was only looking at certain headers. But if you look at zip messages, you're going to have some random values in here. Like Mark was copying the call ID before, and the to and from tag. There's no to tag in this message, but he had to copy that ID, and he had to copy that to actually tear down a call. Sorry about that. And I was looking at those numbers and thought, okay, some of those call IDs just look like timestamps. Some of those tags were just like incrementing numbers and stuff. And I was like, okay, are we actually able to, guess how random those numbers are and guess numbers and actually tear down calls without knowing anything about the device? Actually, it's possible. So we do have unique strings in zip signaling. The most obvious one is the call ID, which is used to identify a call. And if you're using call forking, you do have the to and from tags that become important since the call ID still stays the same. But if you know the call ID, you can just send a cancel or buy request to device and say, okay, please do cancel that call. And most of the devices just look at the call ID in their internal database, the access does, and say, okay, I'm just going to go ahead and cancel that call, no questions asked. And there's some more headers that values might increase, decrease, or might be somewhat random. But what I figured out is, some of them are predictable, which is really bad, and some actually leak information. So I analyzed a bunch of clients and a session border controller. So if you're looking at the ZipSec tool, which is stateless, all it does, it initializes the random number generator, gets a big random number, and just shoves in the random number in the call ID. What I did was I did 70,000 random calls and just did had a look at the call ID. And if you see, the call ID, the maximum value for the call ID is 2 to the power of 31. And it's evenly spread across that field. So guessing a call ID for a call that has been initialized or set up using ZipSec is pretty hard. You won't be able to do that. It's probably one of the best solutions, easiest solutions to actually do random call ID. On the downside, if you like a big media gateway controller and you do have to take care of thousands of calls in parallel, having really random IDs might be a bad idea. But that's up to the vendor to actually get it implemented. In contrast, another command line tool is ZipP, which is somewhat stateful. What you do is you define XML-based configuration files, which contain zip messaging, and you can do everything. You can generate calls, you can register devices, you can mass registration. We used to register like 500,000 devices using that tool in just half an hour or something. But if you look at the format string used inside the program to actually define the call ID, they use an unsigned integer, which is just incrementing, the local process ID, and your local IP address. So if you use like ZipP to do call testing and see if your service is up, and for whatever reason you happen to have the same call ID over and over again, your zip proxy might drop packets and say, okay, I've seen the call and it's already terminated, so I'm just dropping the packet since it looks like a retransmission. So you really run into issues. And if you look what zip signaling looks like, ZipP signaling looks like, if you're doing the test tool, it's really easy to identify that kind of traffic inside your network, even though you specify different user agent and try to disguise it as an AVM router or ZipSec or something. You can just by looking at, or by graphing the call IDs, you're going to see some lines inside your traffic patterns, and you know, okay, it's somebody using some bad tool like ZipP to do some stuff. And if you know it's not you, it might be some attacker. Opal is another interesting library. It's the foundation for, currently it's just Itiga, and it's probably the foundation for lots of private applications that are based on voice over IP. People implemented zip proxies based on that library and some sort of zip applications. And you have to really program your stuff, so there's no way you can just find bugs in Opal itself and say, okay, all the applications are vulnerable, since you have to take care of signaling on yourself. But the way they generate the call ID, they just get a random ID, which is supposed to be unique, at the side and your local host name. So if you look at the mechanism or the function they use to actually get that random ID, that's pretty interesting. They count the microseconds since like the 60 or like the Middle Age, and do some up as like 4 or 5 pages to that, and eventually do some timestamp stuff like timing difference, and then push that data to your call ID and then at your MAC address. So while the random number is really random, it's like milliseconds since the Middle Age, but it still contains your MAC address. So As a matter of fact, it is unique. It's probably pretty hard to guess that call ID, but Opal is leaking information. Like if you've got your soft client hooked up to different ISPs, just by looking at the signaling going to different ISP, you can say, okay, all those packets originate from one particular physical host. Even if you're using two different instances of a key on your same host, it would still have the same MAC address, and you can still narrow it down to one host. You can say, okay, that guy used to be a customer at our ISP, but he moved to that ISP, since now I see his MAC address on that ISP. That's you don't want to have your MAC address in there. But on the upside, if some guy implements like a split bot based on Opal, you can just block the MAC address, and that's it. You won't see the MAC address on your network, but you see it on the call ID. Everybody's talking about Asterisk, so I had a look at Asterisk. We're probably one of the few ISPs that actually get around without using Asterisk. So I won't talk bad about Asterisk or good, since I don't know it. I hardly use it. One of the issues they had was that their random number generator pretty much worked like zigzag, but it wasn't thread safe. So whenever you had several calls coming in at the same point, it might have been that Asterisk issued the very same call ID to two calls. So if one of the calls was torn down from the outside, Asterisk just have looked at the call ID and said, okay, I've got two calls with the same call ID, so I just go ahead and just terminate two calls. So that's one of the reasons why you want to have unique call IDs. That has been fixed in the meanwhile, and there's the bug number for the Asterisk website. That stuff is being discussed and the reasons and yeah, everything. So I'm not getting into that anymore. The TLSI switch is a big media gateway controller. It's probably not known since over here, since it's a German company. And we had a look at that. We're using that, and it's really capable of doing lots of thousands of calls in parallel. But the call ID also contains the MAC address. So that's bad. And then you've got your MAC address. You've got some random prefix. You've got some padding that tends to be 0 all the time. Unless you've got some sort of call forking, you have to figure that out, what that actually is. And you've got some random number. If you now look at the prefix, and you just graph the prefix, you know it's a time base. So it's not random anymore. So I don't have to, once I made a couple of phone calls, I don't have to actually guess the prefix. I can just say, okay, based on the time base that box is running, I know what part of prefix would show up in signaling anytime soon. And the small peaks you see in there, it's so-called retransmissions. Whenever a client didn't reply to a zip message in time, the very same message gets retransmitted. And you can actually fingerprint the timing, like all the timer values set on that box based on that graph, and say, okay, it's retransmitting packets after 500 milliseconds, and it's doing another retransmission after like 1 second. If you really have a close look at that, you can see that those peaks are in a certain interval and stuff. You can look at timers, but I never really had to get into that. And if you look at the postfix, like the second random number, you see that the maximum random value is 10,000. If you go to that, you see the maximum value would have been like 16,000, and they wasted like 60% of the amount of random numbers. The MAC address is fixed. We know that this is a time-based value, so we can actually calculate what that would be in sometime soon. That padding would always be 0, and all we have is a random number between 0 and 10,000. And we have the IP address. So in order to terminate a random call based on that media gateway controller, all we have to do is just send 10,000 messages containing all those random postfix numbers as long as the call is set up. Any given call might be like, 5 minutes long. So if it's sufficient to just terminate that call within 5 minutes, you're going to end up where you have to send 10,000 messages in 600 seconds, which is like 16 messages a second. And you've seen programs doing 1 million packets in like 2 minutes, and zip proxies are usually capable of doing like 20,000 packets a second. So sending 16 messages a second to tear down a call is not that much of an issue. Newport is a session border controller vendor. Session border controllers are supposed to be the solution to all the voice over IP issues we have. billing, security, privacy, you name them. And we have another ISP that is peering with us, and he's doing billing based on that session border controller, and all his traffic is going through that session border controller and is coming into our network. And if I just look at the messages coming in, you can see these wire headers, and they have some random branch. The branch is supposed to start with the fixed part up to the K, and this is all dynamic. And what they do have, the term stands for terminating, so they are terminating into our network. It's not originating from our network. And they've got some ID, as you can see, it's incrementing. And they do have some strings, which happen to be German phone numbers. So even if you suppress your caller ID, you would still see the A and B party phone number in signaling. So they are selling that device for lots of money. And one of the features they advertise is privacy. But still, they have their phone numbers in there. And even worse, you can make drafts. I'm not affiliated with that ISP. We're peering with that ISP, and it's only one session border controller. So just by looking at the traffic, they are sending me, and I don't even have to get the real traffic. I just have to get the so-called options request. I can say, okay, at any given point, they are making 8 calls per second to some other ISP. They're not making the call towards me, but to some other ISP. And I can still say, okay, you're doing 8 calls a second. I can say, okay, you had some network issue at that point. And at that point, you try to shift some more traffic towards that session border controller. At that point, it just crashed, and there you got it back up. And Newport never responded to me. I said, okay, you've got some issues, and I'd like to get those fixed, and I'd like to talk to some tech guy about that. And they said, okay, you're not a customer of ours. You don't have a tech support ID. You won't get any support on that. So that's going to end up on bug track anytime soon. And there's way more you can do with the session border controllers. Caller ID suppression is set, and you will still be able to see all the caller ID information, which is, by German law, they would probably even be not allowed to sell that device right now. So it's really a bad thing, but yeah, they didn't respond yet. There's some related work, which was presented on the third Voice over IP security workshop in Berlin earlier this year, which also goes into the field of looking at headers and existence of headers. And they've implemented an IDS, or intrusion detection system, based on passive fingerprinting. It's not active, it's passive. Just been looking at the traffic that's been sent to their systems. So for the last 15 minutes, I talk about stacks and parsers. It's going to be really, really quick. Each zip device does have a stack inside. You can just try to crash that particular one stack, but it's just limited to one stack. And it's really hard. Once the zip device says, okay, I successfully passed that message, you don't know if what you perceive as is the right parsing is what the device did. So what I did was, there's some slide. I was just comparing zip parsers. I just used 2 different zip stacks and dropped the same packet on both of those stacks and compared the results. And depending on, either one of those stacks might fail, or if you just compare results and say, okay, that stack said, okay, that URI that particular value, and the other stack said something else, you know something is going on. But you would hardly notice that in your live traffic. You just have your zip proxy running. It would just pass a message, it might be bad, but you'll never see that. So the easiest approach was to use the IPTAI-based ZipX browse router, or OpenZer. It's an open source C-based zip router, which is really capable of coping with lots of traffic. And libozip2 is a zip library implemented in C, which is used on cell phones talking voice over IP. It's used on DSL routers. And you've got like Linphone, you've got like GUI-based clients for your Unix desktop. So what I did was I got traffic from a network or from a PCAP-based file. I threw it into libnids, which is defragment all the traffic, since traffic might be fragmented, and then just make both libraries pass the zip message. Then I had a meta structure with like, okay, the call ID was this, the host part of the call ID was that, the request URI, whatever, and then I would just compare the results. And it might be that just one parser failed. Like, okay, I had a colon in here, and libozip failed. Libozip doesn't work well colons and even in comments. You can have a comment in your zip signaling, and libozip won't be able to make a call. On the other side, zip express router doesn't like spaces in URIs, which is, as a matter of fact, illegal. You can have usernames that do have spaces, but you have to escape the space. So it's legal for there to actually die on that packet or fail on that packet. Okay, there's another one. Like OZIP, like the space, OZIP didn't have any issues. The space in the packet said, okay, that's fine. But the zip express router got a packet that has the space encoded. So if you compare the URIs, it's different URIs. So if you're like writing a billing ticket, the billing system might not recognize one of the URIs, but your zip router still knows, okay, that's that particular user. You know that user, you can make that call, or you can call the PSTN, you can spend money, but your billing system won't be able to match that user against the database just by using different types of notation. And actually, there are systems using libozip for lawful deception, and you can just trick them by either using a space sign or adding comma to a comment in zip signaling. So it would have no effect whatsoever on the calls you're making. It's just a comment, but the lawful deception system won't be able to actually see that message and the parser fails. What you see is that the IFTEL zip express router is designed to pretty much ignore bugs if they do happen, and it doesn't even pass the whole message by default. So it doesn't care about the media descriptions. It just passes whatever headers it has to pass and sees, okay, I can establish that call and just send that message off to some other device. But libozip, in contrast, is passing the whole message. It's way slower, and it actually fails, like, many more times, just based on the fact that it's actually passing the whole message. Yeah, that's bad. So, how could we exploit that? Call ID spoofing is the most interesting one. One of the things you can do in Germany, you could have done in Germany like a year ago, was you would spoof your caller ID from a cell phone, and you would just call your own cell phone, assuming that you're calling it from your own cell phone. So it doesn't make any sense to call your own cell phone, so it would end up on your mailbox. But since you're calling from your cell phone, you've got your SIM card in there, and you've got a contract, so you're authorized to call your to call your voicemail without having to enter a PIN number, since you've got your own cell phone, you're already authenticated. So by spoofing your cell phone number from the voice over IP world and calling your cell phone, or calling somebody else's cell phone, you can listen to somebody else's voicemail without having to enter a PIN. You can do some call forwarding settings or whatever. And the way the German government, or Deutsche Telekom, got around that problem was they enforced in policy saying whatever ISP or PSTN carrier is injecting calls to our network that's using a spoof number is liable to whatever amount of fees. So you're just not allowed to inject calls anymore, but they still have the same problem. So it's all the tests that I did was based on our own PSTN network, since apparently Deutsche Telekom is really looking at the network. And if you're injecting fake calls, they might get angry at you. And I don't want to be the first guy at our company to just get busted for that. So how could we spoof the caller ID? As I said earlier, there's many implementations on how to do call ID. You've got the to and the from fields, which is like 5 years ago. Then we've got remote party, which is a draft that's being implemented and standardized by Cisco, and it's present in most of the PSTN devices. And then we've got the so-called privacy extensions, which is like the true RFCs. But unfortunately, the privacy extensions are newer than the zip RFCs. So if some company comes up to you and says, okay, I've got some zip-enabled device, and I want to sell it to you, and it does support the latest zip RFC, yeah, it does support the zip RFC, but it does not support the privacy extensions. So sooner or later, we're going to run into some issue. So what you do is you do a phone call from a zip device, and you add in all the methods you know on how to actually set your caller ID. And the zip proxy might know about remote party ID, but it might not know about peer-asserted identity, which is the privacy extension. So zip proxy, we're doing it on our network, we just ignore the remote party ID set by the client and say, okay, the only remote party ID you're allowed to set is the number that's in your contract. So we just pull the call ID from the contract database and say, okay, just put that number in there if you want call ID. That's the number you're going to show. We're not supposed to show anything else. But if you didn't know about any other RFC or any other standard, we might just leave the PS-certified identity header in there and send it off to our PSDN gateway. Since the guys that are doing our PSDN gateway are updating the Cisco firmware every once in a while, and we're running another software that's where the developers are pretty good, they've already implemented PS-certified identity. And remote party ID is just a draft, whereas PS-certified identity is the latest and best RFC in terms of call ID. They just ignore remote party ID and say, okay, I'm just going to add the number that's in the PS-certified identity. And suddenly in the PSDN, you've got a fake call ID. How do you fix it? On your zip proxy, you have to know what kind of mechanisms you're using for your call ID, and just drop all incoming headers that are used for like call ID. And I talked to a couple of other ISPs in Germany, and we're a small working group trying to get things fixed before they actually become issues. And we had lots of ISPs that didn't really filter out like the PS-certified identity. There's still some ISPs in Germany where you can inject phone calls. You can just sign up for a free contract. You've got 3 minutes to use with your account, and you can make free spoof calls towards the German PSDN, even though it's obviously forbidden, but it just works. It's that easy. Talking about the resources, yeah, obviously get SMAP, but do get the updated version. The puzzle test program is just limited to the Zip Express router. That's what I've written and contributed to that. It's just, if you're an ISP and you're running there and you want to know what messages your Zip server is failing on, you just take that tool, either run it on your live system or run it on a dedicated machine, just throw some PCAP files on it, and you're going to see with methods your box is failing. The stack comparison tool is comparing libozip against either OpenZare or StockZare, and the Zip FP is in there. It's a passive fingerprinting tool that I've written before I started writing SMAP, just to get a basic feel on how things look like. I do have some conclusions. Obviously, passive fingerprinting is possible. We expect that for split countermeasures, it comes in really handy. And we're actually using some sort of passive fingerprinting right now to drop malicious packets from unsupported clients to lessen the impact of all those bad passive packets on our network. And as you can see, active fingerprinting, it's being done. It's pretty accurate. The hit ratio is pretty good, and the identify rate is pretty good. The net and firewall issues have to be solved to actually identify all those soft phones behind nets. What's going to happen in the future? We're going to have more zip extensions, like we had the zip ping method that just came up like 2 months ago, and nobody implemented that. So for fingerprinting, that's one of the prime targets to look at. I'm personally looking at session border controllers more and more. And if you've got some bug in a session border controller, it's a major hassle. And suddenly, instead of dealing with open source, you're dealing with the company that you hopefully have a support contract with. And getting bugs fixed usually takes at least a week to get beta firmware, probably a month, and at some points they just don't respond to you. So having a session border controller might be a major headache. Split is going to probably hit us in like 2 years, 3 years. If you're living in Germany, legal issues are way more important. You're not allowed to drop a call or something without asking for permissions. So running an ISP is not that much of fun if you're looking at all the laws. What I'm going to do in the future is implementing a passive fingerprinting system that's probably going to be incorporated in some infrastructure just to look at traffic and identify malicious content before it actually can cause any damage. Nothing would be that interesting without having some zero day in here. We're running Cisco PIX firewalls. It's several POPs, and it turns out that if you enable zip inspection and you've got a zip device behind a net that's registering to an outside zip server, you can open up whatever port you want based on UDP, TCP, you name it. probably access internal servers from the outside just by shoving in one additional contact into the 200OK method that you can fake from the outside. It's really easy to do, and the contact will not be checked. We had a look at the debug output, and it was like, okay, that's not happening there. It's too easy to actually do. I'm not offering any predefined exploit, but if you're interested in how to do that, just come talk to me. That's really easy to do, and we're talking to Cisco right now to get it fixed. Thanks for your time, and I think. Okay, I thought okay. I thought I had like 5 minutes. So okay, we've lots of time for questions. So yeah, go ahead. Any questions? Yeah, sure. I wanted to. The question was what version of the zip firewall I was using. I wanted to look that up, but unfortunately I lost my RSR token like 1 week ago, so I wasn't able to look it up. It was, I think it's like 7.3 or whatever, the latest version. We actually updated the one of the fixed firewalls to just see if it's fixed in the current version, so it's still in there. Any more questions? Okay, yeah. I'll be here for another 2-3 days, so just come up to me if you're looking into any particular exploits. And thanks for your time.